Now let's say I want to solve this question. The question is longest remaining time first. Just like shortest remaining time first, it is longest remaining time first. The difference is there we have been taking the shortest jobs and then we'll stop after executing every job for some time, and then we'll see if there is any new job which is having a shorter burst time. Here we do the same thing. We start with some job and then execute it for some time and then stop and see whether we got any new process which is having a longest remaining time or longest burst time, and then we could continue it that way. And now there is a chance that see the basic difference is like, maybe you could think of this longest remaining job first as like this. Let us say in your two hands you have two bread and one bread is longer than the other one. Then maybe you'll bite the longer one first, and then you'll find it out that the other one is now the longer. Then you take it and bite it, and again you'll find out that this one is longer, bite it, find out that this one is longer, bite it, right? So that is how this is going to work. So whenever one process is longer, we are going to take it and then schedule it, but after executing for some time the other one becomes longer, and now we'll take the other one and execute it, and this keeps on happening, right? So now just watch it. So very simple, but then you should be really careful about the details. In the sense, you have to keep track of many things here. One is what are the process available and what are their burst times, and then what are their arrival times. And one more thing, whenever two processes are having the same burst time, we shall pick the one with the lowest arrival time, right? So even though I start the Gantt chart at 0, I'm not going to schedule anything till 1, right? So because one is the earliest arrival time, so I am going to take process P1 and run it for 1 unit, which means till 2. Therefore its burst time will now become 1. Now at time t equal to 2, we got one more process available, which is P2, and its burst time is 4. Now among these two burst times 1 and 4, it is clear that 4 is longer. Therefore I am going to schedule 4 first. So P2 I am going to schedule it and run it for one more unit, and now its remaining burst time will become 3. Now the time is 3. Now by the time 3, P3 is also available, and now if you check it, 1, 2, 3, all the 3 processes are available, and the longest one is P3. Therefore P3 gets scheduled and we shall run it for 1 unit, and now we shall check what is the time and what have arrived. Now the time is 4, and by this time 4, all of them have arrived, and among all of them the longest one is P4. Therefore I am going to schedule the P4 first, right? And I am going to run it for how long? When all the processes have arrived in the shortest job first, shortest remaining time first, what we did is we converted that to shortest job and we have finished it off. But then here the difference is you cannot convert the algorithm now to longest job first, which means you cannot take this longest job and then finish it off. The reason is, after executing for some time this one, someone else will become longer. See, after executing 3 units of P4, then P3 will become 5 and P4 will become 5. Now there is nothing, now P4 is no longer the longest one, isn't it? Therefore the longest one, there is a tie. So what you should do is run a process until some other process becomes the longest one, right? So that is the method you should do. But anyway, I think it will be directly difficult for you to observe it. So let me go in step by step. It will take some time, but then in exam what you should do is, whenever you are scheduling this 8, you see that how long I should run it so that some other process will become the longest. If I run it for 3 units, then the next process 5 will become the longest, right? Then I'll take this one and I'll alternate. Okay, fine. Let me do it first. You will understand it. With more examples I'll make this point clear. Now I'll run it for 1 unit, only 1 unit, so that it will be easy for you to understand. Actually I should have run it for more units, but then to make the thing simple, I'm running it for 1 unit, P4. Then what happens? This one will become 7. Now which one is the longest? Again P4. Therefore I'll again pick P4 and run it for 1 unit, right? Then what is it? It is going to be 6. And again a longer one is P4. Let me pick P4 itself and run it for 1 more unit, so which is 6. 7 here, and now it will be 5. Interesting. Now watch it. Two processes have the same burst time, which are both showing 5. Therefore both are longer. Then which one should I choose? I told you that whenever there is a tie between the burst times, the tie is going to be broken by considering the arrival times. So whichever has arrived early, that one I am going to take it. So there is a tie between P3 and P4 and the early process is P3, so I am going to take P3 here. P3 I am going to schedule it for one time, then this will become 4. Now which one has become longer? P4, right? So I am going to take P4 and schedule it for 1. Okay, it is 8 and it is 9, right? And now this one has become 4, right? And again, which one has become longer now? P3, depending on the arrival time. Then I'll schedule it for one more time and it is going to be 3, and again P4 becomes longer, so P4 I'll P3 or P4. Now P2 has also come into picture with the same time as P3. Therefore, you should run P3, P4 and P2 and then P3 and then P4. And again the same thing will repeat, right? So I have to run P2, P3 and P4, right? So it is going to be 2, 2 and 2 now, isn't it? It will be 12, 13, 14. Again you run them for one more time. Now P2, P3, P4, because all the bus times are same and they are longest and they are all according to the arrival times. P2 is first, that is why P2 is scheduled, then P3, then P4, right? Therefore this one will become 1, 1 and 1, and this one will be 15, 16 and 17. Right? And now if you watch it, all the 4 processes are now having the same bus time, which is 1. Now what you should do is you should schedule them, all of them, one by one. So which one will get top priority? P1 because of arrival time, then P2, then P3, then P4, right? Therefore this is how all the process got completed, right? Then what is the finishing time of this? It is 18, 19, 20 and 21, right? So what is the advantage of this method is no process is going to complete until the longest process also approaches completion, right? It is not like any other algorithm. All the other algorithms, the shorter one, at least the shorter one will be finishing it early, right? But here, even though a process is very short, even though it requires only 2 units of time, it will be postponed till the other process will reach the same time, which means all the process will actually approximately finish at the same time. If you look at the completion time of P1, P2, P3, P4, they are very close, right? Because we are pushing all the process till the end. If a process is having longer burst time, then we are going to complete it first, but we are not going to completely finish it. We are going to just push all the process till the end, so that all of them are going to complete at the same time. Now if you watch the completion times, watch it. What is the completion time of P1? P1 completed at 18 and P2 completed at 19, P3 at 20 and P4 at 21, right? And now we can find out the turnaround time. Turnaround time is completion time minus arrival time. Now turnaround time is, the first one is 17, second one is 17, third one is 17 and fourth one is 17. Interesting. All of them are getting the same turnaround time, right? And now what about the waiting time? Waiting time is turnaround time minus burst time. So how much is that? Waiting time for this one is 15, waiting time for this one is 13, waiting time for this one is in this case it is 11, and waiting time for this one is 9, right? Fine. And then we could even find out the response time. What is the response time? You see the first time a process got scheduled and when it has actually arrived. So since its arrival till its first scheduling, what is the time elapsed? Now we can find out the response times like this. Response time. For the first one, response time is, first one got scheduled at time t equal to 1, and when did it arrive? At 1, which means whenever it has arrived it got scheduled, therefore it need not wait for any response. It is actually, response time is 0, it immediately responded. And what about P2? It got scheduled for the first time at 2 and it arrived at 2, therefore response time is 0. What about P3? It got scheduled for the first time at 3 and it arrived at 3, therefore response time is 0. P4 the same thing, it got scheduled at 4 and it arrived at 4, therefore response time is 0, right? So you can find out what is the average turnaround time, what is the average waiting time, and what is the average response time. In this example, it so happened that response time of all the process is 0, but then it need not be true, and it is not true for all the examples of this algorithm, which means here it so happened that whenever a process has newly arrived, it turned out to be the longest process available, and therefore it got the chance to execute immediately. That is why response times are all zeros, but then it is not true for everything. Okay. Now the interesting thing is everything is going to be finished. Okay, with some more examples we shall analyze it, right? Instead of analyzing it with this simple example, same example, we shall analyze it with more examples. And you please take care while executing this, because it is not as easy as the other ones. You should keep track of what is the burst time, and along with that you should be keeping track of the Gantt chart. Okay.